Hello students, good morning. Okay, uh, we have only short time to attend your examinations, isn't it? So I already told you, sit and study every day at least 10 hours, then only it will be, you can easy to crack your NEET examinations, understood? So concentrate all the subject, not only one subject, maths, you know that physics, chemistry, as well as biology, understood? Okay, so every day you complete at least one lessons. Okay, we also we are going to complete at least one lessons per day. These are all very big lessons. Okay, so you also study at least one lessons per day. Okay, one subject I am saying. Okay, the not physics one lesson, chemistry one lesson, as well as biology one lessons. Then only you can able to complete your portions. Understood? Okay. Okay. Now I'm going to teach one lesson in plus 2 portions, that is called solutions. Okay, this also we have some compulsory. We will be getting one problem in this chapter. Okay, as well as we have theories also there. Okay, so easy lesson. We have two parts in these lessons. Okay, one is about solubility, Henry's law, Raoult's law. Okay, so based on statement, we have one topic is there. Another one, we have colligative properties. Another topic. We have two topics in these lessons. Okay, so first one I'm going to teach only the mostly they will ask problem in colligative properties, I expect. Okay, so first I'm going to complete the colligative properties. After that I'm going to teach the Henry's law, Raoult's law. That okay, the topics I'm going to teach. Understood? Now, generally what is solutions? Solution is consist of solute and solvent, you know that. Okay, if solvent is more means that kind of solution is called what? If solvent is more means dilute solution. If solute is more means what? Concentrated solution. You know that. Understood? Okay, so anyhow, if there are any solutions, it consists of solvent and solute. Okay, so here based upon this only we are going to study some statement. Okay, so first one I am going to take here colligative properties, simple one, colligative properties. Okay, see, colligative properties nothing but it depends upon number of solid particles in the solution, number of solid particles. If you have, suppose here for example, you know that I am taking water is a solvent. Okay, suppose what is the boiling point of water? What is the boiling point of water? What is the solvent? No doubt. Water is a solvent. It boils at 100 degrees Celsius. Understood? Okay. Now, if you know that, now if you add any solute, if solute means if any salt is present. If any salt is present means it will not boil at 100 degrees Celsius. Okay. If you add solute to solvent, that is considered as what? Okay. If you add solute to solvent, so suppose here, I'll write it here. First I am taking only solvent. Next one, to that solvent I am going to add solute. Now only it's called what? Solution. Are you following? Understood? Okay. If you add solute to solvent, now only it is called what? Solution. Understood? Before that we have only solvent, now we have solutions. Understood? So now before that it boils at 100 degrees Celsius, now it boils at more than 100 degree, not, okay. So if you take boiling point means here, it boil, now it is not boiled, it consists of solute, no. There is an interaction between solute and solvent. Now the solution's boiling point will be more than 100, it may be 110, it may be 120, depends upon the number of solid particles you are adding. Okay, that's why it's called, solution. Some, the boiling point increases, depends upon the number of solid particles present in the solution. How much solid you are adding, that much boiling point will be increases. Okay, then only this is called what? Colligative properties. Colligative properties nothing but it depends upon what? It depends on number of solid particle. That's a point. Number of solid particle present in the it depends on number of solid particle present in what? In solution. Are you following? Understood? So if your number of solid particle increases, boiling point increases. If you take freezing point means decreases. Some changes taking place. Okay. So how much solid particle is present inside the solution, that much properties increases. Properties means we are going to study about boiling point, freezing point, osmotic pressure, vapor pressure. 4 properties we are going to study. Okay. You just write. First you write this only. It depends upon, you just write short form. It depends on number of solid particle present in solution. It's called colligative properties. Understood? Are you following? This only write, is enough. This only write. It depends on number of solid particle present in solution. Understood? Okay. Then what are all colligative properties means, types, you just write. First one, lowering of, just write all the properties. Lowering of vapor pressure. Okay. Next one is elevation of boiling point. Third one, depression of freezing point. Can you able to follow? BPT means what? Boiling point. FPT means what? Freezing point. Okay. Fourth one, osmotic pressure. Understood? Osmotic pressure. Okay. We have symbol for this. Each and every one we have symbol for this called del P. Okay. This called del TB. Okay. Depression of freezing point means here del TF. F stands for freezing point. Okay. Osmotic pressure means we are represented by pi. That's a symbol. Okay. These are all colligative properties. This will be changes, increases or decreases. Depends upon what? Depends upon what? Number of solid particle. If you have more number of solid particle, this will be changes. It may be increases or decreases. Okay. If you take vapor pressure means decreases. Are you following? If you take boiling point means increases. If you take freezing point means what? Decreases. Understood? Osmotic pressure. This also based increases. Suppose if you have number of solid particle increases means, or if you have highly concentrated solution, this also increases. Okay. Or simply they represent osmotic pressure. Okay. Understood? Each and every one we have some symbol for this. Okay. Right. Now we are going to see one by one. So I am going to give only the formula for each and every one. Okay. Based upon we have some sums will be there. Problem. Understood? Okay. First you write. First one, lowering of vapor pressure. Understood? Lowering of vapor pressure. Understood? See, you know that before that you must know this and all. What is P naught? What is P? What is T naught? What is T? This is all you know. See, naught represents, you just remember, solvent. Okay. Okay, just remember. Okay. P, no, P means we consider it as a vapor pressure. So what? Vapor pressure of what? Solvent. Okay, not represent. Suppose here nothing is there, no. I simply put like this. Okay, this represents what? Solution. Just remember. Okay, then only able to solve the sums. Now, nothing is there, no. This is vapor pressure of the solution. Solvent and solution will be coming here. Suppose T naught. T naught means what? Temperature. Temperature, it may be freezing point or boiling point, anything. Okay, I simply write temperature of what? Naught means what? Solvent. You just remember. There is no naught means what? We can say it's called solution. Remember like that. Okay. This one. This term you must know. If nothing is there means I put hyphen, so no. Okay, then it is called solution. Understood? Then one more thing I written. Then one represents solvent. Another way. This term and all you must know. Two represents solute. Solute. Here solvent and solute. Here solvent and solution will be coming. Understood? Say for example, this one keep in mind. W1, W2. What is the meaning? W. Mass, no? Mass of what? Solvent. Mass of solid. So this only just remember. Are you following? The formula we have 1, 2 will be there. 1 means you must know that's called solvent. 2 means you must know it is called solute. Understood? So what here we can say mass of solvent is called what? Mass of solute. So M1, M2, right? What is M1, M2? Molar mass. It's called mass. You can say it's called what? Molar mass. Everything they will give. You substitute and we can get answer. So molar mass of what? Molar mass of the one represents solvent. Okay. Solvent. This is called molar mass of solute. Understood? X1, X2. X1, X2. X1, X2. Mole fraction. Simple. All the symbols you must know. Mole fraction. Mole fraction of what? Solvent. This is mole fraction of solute. Understood? Okay. Then here, I'll write it here. N1, N2. Number of moles of what? Solvent. Number of moles of solute. That's all. So I'll keep in mind. Then only you can able to solve the sums. Okay. The formula we have 1, 2 like that. Okay. Understood? This only keep in mind. Okay, here not, I put simply dash, not, okay. This is somewhat different one. Solvent and solution will be coming. Here solvent and solute will be coming. 1 represents solvent, 2 represents solute. Okay, right. Finished? Okay. See that? Okay, see, now first statement is what? Lowering of, so you already put the heading, lowering of vapor pressure. See, you know that suppose I am taking only solvent, okay, it produces more vapors. When you heat means that produces more vapors, only solvent, okay, no solute is there. If you heat the solvent, more vapor pressures are coming. Okay, or more vapors are coming, that produces pressure. No, the pressure produced by the vapor is called what? Vapor pressure. Okay, so only solvent, more vapors are coming. It is called what? P naught. Understood? Only vapor pressure means solvent means, for only solvent means vapor, P naught. Now, to that solvent, I am adding what? Some solute. Now it is called what? Solution. No, it is called what? P. Are you following? Now, if your solute is present in solvent, that much vapors will not come. Here more vapors are coming. Okay. Here that much vapors will not come, because there is a interaction between solute and solvent. then only now more vapors will not come. Okay, so vapor pressure decreases. When we add solute to solvent, vapor pressure decreases. Then only we can say what? Lowering of vapor pressure. That's a term. Okay, so when we add solute to solvent, vapor pressure decreases. Okay, just copy them. This one, be quick. First you write, when we add solute to solvent, write in short way. When we add solute to solvent, vapor pressure decreases. When we add solute to solvent, vapor pressure decreases. It is called lowering of vapor pressure. It is called lowering of vapor pressure. That is represented by del P. Okay, so that is represented by del P. Who is having more vapor pressure? P naught or P? P naught. Okay, so what's the formula? Therefore, the formula is what? Del P is what? P naught minus P. Can you say like this? It's only having more, no? Okay, when compared to this. So, del P is equal to P naught minus P. This is the formula for that. Okay, simply they will give the two values, you subtract it, you can get an answer. Okay, this is the formula for lowering of vapor pressure. This is the first formula. Okay. If you want means you put the diagram roughly. Okay. Sure, right. Then another one, del P by P naught. This is nothing but relative lowering of vapor pressure. Relative lowering of vapor pressure. Another term is relative lowering of vapor pressure. Relative lowering of vapor pressure. Okay, only del P lowering of vapor pressure by ratio of, can you say like this, ratio of lowering of vapor pressure and vapor pressure of the solvent. Ratio between lowering of vapor pressure and vapor pressure of the solvent is called what? Relative lowering. Okay, so if you have relative means we have to relate the two quantity. That's called relative. Okay, so that's called what? Relative lowering of vapor pressure. It's a ratio between lowering of vapor pressure and vapor pressure of the solvent. Okay, now here how to write this one? Del P. Del P nothing but what? Or we can say the same thing. I'm going to write P naught minus P by P naught. Correct or not? Both are same. Instead of del P, I put what? P naught minus P by P naught. Okay, just copy them. Simply suppose here P naught is, that is for example 5. Okay, P is what? 2. Find out relative lowering of vapor pressure. What's the answer? They'll ask like this. Vapor pressure of solvent is 5. Vapor pressure of the solution is 2. Find out relative lowering of vapor pressure. So what's up? How to apply? So 5 minus 2 by again 5. So what? 3 by 5. Understood? It goes on. Okay, just note down. Examples. We put on examples. Write like that. Therefore, relative lowering of vapor pressure. You write. Okay. Understood? Okay. It's another formula. Okay. Now, I'm going to give the final formula. That is, del P by P naught is equal to P naught minus P by P naught. Okay, which is equal to, they are saying x2. X2 nothing but what? Mole fraction of the 2. 2 means what? Solute. Are you following? Okay. So they are relating all this. Okay, this relation depends upon only mole fraction of the solute. Understood? Then only, mole fraction means we have one formula, no? What's the formula for mole fraction? N2 by N1 plus N2. Understood? So, if you take dilute solution, this concentration is very, very small. Then only we are neglecting this one. Okay. So then only when compared to this, okay, when compared to 1, okay, 2 will be very, very less. Then only we are omitting, we are neglecting that one. So it will be N2 by N1. So what? N2 by N1. N means what? Number of moles. Number of moles, what's the formula? Mass by molar mass. Understood? 2 na, here also put 2, 2. Understood? So substitute here. Therefore, similarly what? N1 is equal to W1 by M1. Okay, understood? So what? W2 by M2 into M1 by W1. So, okay, don't worry about that. This formula only just memorize. Okay, that's all. This is the final formula. Understood? All this formula also you must know. This is also one formula for mole fraction. This is a formula for what? Number of moles. Okay. This is the formula for lowering of vapor pressure. Okay. P0 minus P by P0 is equal to W2 by M2 into M1 by W1. It's the formula. So based on this formula, I put one sums in problem solving session. So if you want means you go and see that, you can able to understand all this. Understood? Okay. Based on 4 colligative properties, I put one sums. So first you just memorize the formula. So if you see one sums based on this means you can able to understand. Okay. Now you know what is 1, what is 2 and all you know, isn't it? For examples, see 5 gram of glucose in 500 ml of water. For example, I am saying 5, which is solute, 5 gram of glucose in 500 ml of water, which is solute. This is what? Solute, no? This is what? Solvent. Solute I considered as 2, no? Solvent is considered as 1. Now you know what is W2? These are all W2, M2. Understood? This is what? W1, M1. Understood? So question will be like this. 5 gram of glucose in 500 ml of water means you must know what is W1. Then only you can able to substitute and get the answer. Isn't it? Okay. Tell me. What is 2? No. W2. So M2. This is what? W1, M1. Now tell me. W2. 5 gram. M2. Glucose, you know the formula. What? Just not memorize. 180. C6H12O6, 180. Understood? W1. W1 is what? Find ml, no. So I put gram. Yeah, understood? 500. Here mostly colligative properties in lowering of vapor pressure, all the solvent is measured in gram only. They will give because W1 is coming, no volume term. Understood? Okay. 500 gram. 18. Understood? 18. Tally, no? Okay, then it will be cancelled. Okay, so that kind of sums only they will give. Okay, so if you want means you go through, you go and see the sums in problem solving session. Each and every properties I put one sums. Okay, okay. Are you following? Yes, sir. Right. If you want to just copy them, this one. This will be very useful. You must know what is 1, what is 2. This 1, 2 and all they will not give in the problem. Okay. What is not? Okay. Finished? Okay. Next one. What's the next one? Right yourself. What is the next one? Next property? What's the next property? Right. Second property, you put elevation of boiling point. Understood? Simple one. Second one is what? Elevation of boiling point. Understood? Okay. That is represented symbol is what? Del TB. So I told you already. Okay. So if you take only solvent, what is the solvent? No. Okay. What is the solvent? You know. If you measure the boiling point, means it is considered as T0. Okay. To that water, I am adding what? I am adding some solute. Understood? Solute. Some salt is added. Okay. What happened? That is called what? Solution. It is considered as T. Are you following? Solvent is T0. Solution means T. Okay. Oh, okay. See what's the term? When we add solute to solvent, boiling point increases. Okay. That's a characteristic of, that's a property of boiling point. Okay. If you have more interaction between solute and solvent, so it will not ease to boil. Okay. So if you want to, more interaction will be there. If you want to make them to boil, you have to give more temperature. Then only boiling point it will boil. Understood? Okay. So what happened? So del TB is equal to, who is having high? T. So T minus, last time we studied what? P naught minus P. Is it T minus T naught? Understood? So differentiate. Okay. Now write. Just copy them this one. After that I will give one statement. First, if you see the picture, you can able to understand, I think. Okay. Picture gives more explanation than no statement, isn't it? Yeah. So if you see this picture, you can able to understand. Okay. Now, outright. When we add solute to solvent, boiling point increases. When we add solute to solvent, boiling point increases. So it is called elevation of boiling point. Boiling point increases. When we add solute to solvent, boiling point increases. Okay. This is one formula. Okay. Each and every properties we have some small one or two formula. Okay. Just here, see. Then usually del TB proportional to, it is directly proportional to KB. Actually, it will be like this, directly proportional to KB. Then you put one proportionality constant, KB, m nothing but molality. Okay, del TB is equal to m into KB. KB is called, boiling point constant. This is called elevation of boiling point. Okay, increase in boiling point. This is called boiling point constant. Okay, here m nothing but what? I told you, molality. Molality means what is molality? Number of moles of solid by mass of the solvent in kilogram. Now, just remember, it's a formula for number of moles of solute. Then I put what? 2 by mass of the solvent in mass of the solvent. Then I put what? 1. Are you following? Number of moles of solid by mass of the solvent in kilogram. This is a formula. Okay, you substitute here what? N2 by W1. Correct? Mass of solvent in kilogram, you put 1000 in numerator. Okay, so 500 gram is given. Convert to kilogram, 500 by 1000. So always I use the 1000 in the formula itself. Okay, then we can easily substitute. Mostly gram only they'll give. Okay, so 1000 gram is given means 1000 here, 1000 cancel. Okay, what is N formula? What is N? Mass by N, number of moles. Mass by molar mass. If I put 2 means what? Understood? No. Now what? W2 by M2, already W1 into 1000. Are you following? Del TB. This is a formula for that. Okay? Just copy them. Finished? Okay. Okay. See here, KB just mentioned. What is KB means? All this you mentioned. Okay. This is all already I told you. Beginning itself. What is W2? I told you. Okay. This is what? Mass of solute. Molecular mass of solute. Solvent. Understand? KB is called. Here I didn't miss KB. KB I didn't put. No. Correct or not? KB, no? Correct or not? KB you put. KB you put. KB. KB is called, in this case, ebullioscopic constant. Ebullioscopic constant. Understood? Its unit also very, very important. Kilogram Kelvin per mole. That also note down. Unit. Okay. Ebullioscopic constant for 1 molar solution. 1 molar solution. It's a standard value. Okay. Whatever solvent you are taking, that value they will give. Okay. Which solvent? Suppose water if you take means 0.52. The value they will give. So you substitute here means okay. Anyone will be unknown quantities. Okay. Understood? Okay. Understood? Are you following? Same thing. Depression of freezing point. Okay. Same thing. Suppose here everything. Here B means what? Boiling point. No. Freezing point instead of B you put what? F. Small changes, but everything same. Okay. This only we have to see what? For boiling point it will come T minus T naught. For freezing point what? Decreases. No. So this will be opposite. Here only small changes. Here only small changes. Okay. But everything same. Okay. See. Third properties. Just write depression of freezing point. Understood? Third one is what? Depression of freezing point. Del T F. Understood? As usual, same thing. If you take only water, it freezes at, what is the freezing point of water?
100 degrees Celsius.
Freezing point. Boiling point means 100 degree. Freezing point means what? What? 0 degrees Celsius. No, clear? So, to that water, if you add any solid is present means it will not freeze at 0 degree. It will take more time to freeze. Okay. So the freezing point decreases. No. If it contains some solid particle, it will suppose it may be -1, -2, -3 like that. Okay, so freezing point decreases. Depends upon the presence of solid particle in solution or in solvent. Understood? So then only what? So which value will be higher? Which value will be higher? It is 0 degree. If you have any solid is present inside solvent, again decreases, no. So which value will be higher, T naught or T?
T naught.
T naught is higher. So what?
T1 minus T2.
Understood? Okay. Del T F. Understood? Now del T F directly proportional to F. F is called, Kf is called, freezing point constant. Simply you can say freezing point constant, or we can say cryoscopic constant. Cryoscopic. Okay. Cryoscopic constant. See here. Just copy them one by one. F is called, cryoscopic constant. Cryoscopic constant for 1 molar solution. This is also known value. They will give the value. Okay. These are same unit. Unit also same. Kilogram, Kelvin per mole. Okay. Same unit. Okay. Other things you just change. F. This is what? F. This is also F. This is also F. Understood? This is called freezing point. Depression of freezing point. When we add solute to solvent, freezing point decreases. Okay. Then only they are adding some, salt, no. Okay. The ice cube, if you want to maintain the ice cube acidities for a long time, means they add some, they put some salt. If you add more number of salt around this, means it will be the temperature always maintained less than 0. Understood? So understood. So salt is more number of salt is, or if you increase the number of solid particle, the freezing point decreases, goes on decreases. Okay. Are you following? Okay. Suppose for example 5 gram solid is present, means it goes to 0.5 degree decreases. Suppose 100 gram is solid, if you add, means again it will be minus 3 degree. 200 gram is present, means again minus 7 degree. So mass of the solid increases, freezing point goes on decreases. Understood? Following? Okay. Also based on, okay, so they will give one sums. Okay. So what is W1, W2, M2, this and all, if you know, means you can substitute and get the answer. Okay. Mostly Kf is a known value, they will give. This only statement I gave, 5 gram in glucose, like that. So if they give like this, means you can able to find out this one. Okay. Mostly they will give in gram. Then only I introduce 1000 in formula itself. Mostly gram only they will give. So you don't worry, 500 gram, 500 you put it, that's all. Then you can cancel. Understood? So then only I introduce the formula itself, 1000. Okay? Right. Did you? Are you finished? Okay. Next one is what? What's it? The fourth one? Fourth one is what? Osmotic pressure. Understood? Osmotic pressure. That is represented by symbol pi. Okay. See, simple one. You know that you studied this term in biology. You know that. Suppose here I am taking one vessel. This vessel is separated by one thin membrane. That membrane is called what? Semi-permeable membrane. Permeable means what? Semi-permeable membrane. Okay. The membrane which allows, permeable means allows. The membrane which allows only smaller particle. It will not allow the bigger particle. Okay. So I am taking one vessel. The vessel is separated by two compartments by using one semi-permeable membrane. Okay. Left hand side I am taking dilute solution. Right hand side I am taking concentrated solution. Okay. In dilute solution, which quantity will be higher? Dilute. More amount of solvent. Okay, understood. In dilute solution, Understood? Are you following? In dilute solution, solvent quantity is more than solid. Are you following? In concentrated solution, what? Solute is more than solvent. Are you following? Understood? But when size, when you compare to the size, if you compare means O is smaller means now it allows only through this, it has minute pores, minute holes are there. Through this, it can allow only solvent. So when you take the size, solvent is smaller than solute. This is keep in mind. Okay, very important. Okay. If you take the solution like this, what happened? The solvent molecules moves from here only more amount of solvent, no? Okay. The solvent molecules moves from dilute side to concentrated side through semi-permeable membrane. That process is called what? Osmosis. First of all, osmosis, Then only after that only we have osmotic pressure. Understood? So osmosis means movement, movement of solvent from dilute side to concentrated side through semi-permeable membrane. That is called what? Osmosis. Understood? Okay, How long it is moving means? How long it is moving? Still both getting same concentration. Understood? See, if both getting same concentration means the movement will be stopped. The osmosis process will be stopped. Understood? After that, same concentration, okay, but different concentration I am taking. Then only there is a osmosis taking place. Understood? Okay. Now, if you want to stop the osmosis process, what we should do? We should apply some pressure in concentrated side. That's very important. Don't apply any pressure to dilute side. If you apply any pressure to dilute side means the movement will be very fast. If you want to stop the movement, we are giving some pressure. So the pressure is given to concentrated side to stop osmosis. That's called what? Osmotic pressure. Are you following? Understood? This is all you know. Okay. So suppose here sometimes we need more pressure, sometimes we need less pressure. Depends upon what? If you have more solid particles plus means we have to give more pressure. If you have less amount of solid particles plus means somewhat less pressure we have to give. Understood? Okay. So anyhow pressure is given to concentrated side to stop osmosis. That's called what? Osmotic pressure. Understood? Okay. This is all you know. Okay. You just copy them. This one diagram first of all. This is not important. Size very, very important. Okay. When compared to solid and solvent size is smaller than solid size. Then only through this, through this membrane, who is traveling means only solvent only traveling. Okay. The statement are all, osmosis, osmotic pressure. Okay. Understood? Okay. Then here also we have some formula. Okay. So it is represented by what? Pi, I told you, So here pi directly proportional to, C and T. What is C means? C is called concentration. I told you, if you have highly concentrated means we have to give more pressure to stop the movement, to stop the osmosis. Okay, if you want to stop means we have to give more pressure. Okay, so pi is directly proportional to concentration and also temperature. If you have more temperature inside the solution means we have to give more pressure. So this is a formula. From this we can write what? This is called put on constant. R is called gas constant. Okay, C T. R C means nothing but concentration. That is N2. I told you molality means I told you Molarity is what? N2 by W1, correct? In every boiling point and freezing point, M is called molarity, N2 by W1. But here N2 by V is called molarity. Molarity means RITY. Molarity means solvent should be in volume. Okay, here solvent should be in gram. Sir, not solvent should be kilogram. It should be measured in kilogram, it should be measured in liter. Understood? This is called molarity. This is called what? Molarity. RITY. Understood? So they substitute, that's all, N2 by V T. What is N2 formula? Usually we are writing, W2 by M2. Then what? W2 by M2 into V T. Then as usual, put 1000 in numerator. Volume of the solution in liters. That's a statement. So you put always 1000 in numerator. This is a formula. Are you following?
Yes, sir.
Okay. Mostly R will be gas constant. R, we have three kinds of R. Leon, 3R, not that R. One movie is there, no? Not that R. We have three kinds of R. One R is measured in joule. One R is measured in, liter atmosphere. One R is measured in calories. Okay, we have three kinds of R. But here we are using only, liter atmosphere, 0.082 liter atmosphere per mole. Okay. R is equal to 8.314, you studied. Do you remember? 8.314 joule per mole per Kelvin. Or we have three kinds of R. There are three values of R. In this case, mostly we are using. Pressure term is coming, osmotic pressure, atmosphere, liter atmosphere, that only we should use. Temperature always in Kelvin, okay. 27 degrees Celsius means convert into Kelvin. 27 plus 273, 300 Kelvin. Yeah, okay. All the methods you see one sums, that's all. Okay, how the sums going on, what's the formula, okay, which one is W2, which one is W1, means we can understand all this. Understood? Okay. You following? Okay. So we completed colligative properties. The four properties we completed, isn't it? So based on you'll be getting one sums. Okay. Any one formula. Okay, see next one here. One more thing, you just put types of solution. Some theoretical part are also important one. Types of solution, they classify into. Then you just mentioned in osmotic pressure. Just mention one more thing is there. You just write reverse osmosis. Generally, you know that. What is reverse osmosis? Reverse osmosis means what?
From concentration to
Concentrate to dilute. Suppose here I am taking, due to the, suppose if there is no water in the earth, we have to get water from only sea, no? Okay. So how to get drinking water from sea water. So if you want to get drinking water from sea water means we have to do what? Reverse osmosis process. Understood? You take sea water in one side, separated by what? Semi-permeable membrane in normal water. Okay, normal water in the other side. Okay, it's called what? SPM. Just I'll write it here. SPM. Understood? Okay. Okay. So I told you, if it is, this is highly concentrated, no? Because more solid particles are there. Okay, so we have to give more. If you keep as it is, means what happened? Usually the water will come, no, solid molecules will come from here only water. Here sea water, it contains salt is present. No, okay, so usually the osmosis is taking place. Okay, if you want to avoid osmosis or if you want to stop osmosis, we have to give what?
Pressure.
More pressure. We have to give more pressure. So uh, if you give some pressure means we can stop osmosis. Okay, but you have to give more pressure than osmotic pressure. Then only we can push the, here overall pressure here. What is seawater? It contains solvent and solid. No. Okay, solvent only is a water. Solid is called, salt. Okay, we are going to get water from seawater means we have to give more pressure than normal pressure. So then only we can push water this side to that side. Understood? If you give some pressure means we can stop osmosis. But we want to get water molecule, no? So then only we should give more pressure than osmotic pressure. Then only we can push the water molecule from seawater side to the normal water side. Okay, then only we can get water from, we can get drinking water from seawater. Okay, that's why it's called what? Reverse osmosis. Understood? So this membrane should be very thick. Okay, normally if you give pressure means this is not normal membrane we can take, but it should be, now we are giving more pressure than osmotic pressure. Then only it should be very thick. Then only we can do the process. Understood? Okay, that's called reverse osmosis. This is all you know. Okay. Then one more type. Have you written all this? Just write. Usually we put an arrow mark this side to that side, no? Yeah. But you give more pressure than osmotic pressure, then only we can push the water molecule from this side to, seawater side to, normal side. Okay, then only we have to give more pressure. Okay, right. Next one, you put, then one more thing you just mentioned. Mostly, in all the cases, we are finding molecular mass. What's our aim means to find the molar mass of the solute. Okay, all the four properties. What's the aim of these properties means to find out the molar mass of the solute. All the cases M2 will come, no? All the formula M2, all. Yeah. So molar mass of a solid, if you want to find means we can use this formula. Especially in the fourth property, fourth property, you just write down. Molar mass of polymer can be found out by this method. Only by this method, not other method. Molar mass of polymer. Okay. Other method, we can find out other solute particles. So polymers, if you want to find out the molar mass, we can follow the osmotic pressure method. Okay. Here also M2 is there or not? Here also the formula having M2 or not? What's the formula? Pi is equal to RW2 by M2. No, that M2 is there. No, so M2 is the molar mass of the polymer. Okay. Mostly polymer molar mass we can find out by this method. Okay. Okay, understood? Right. It's only theoretical part, but when you do the problem, then only you will be getting 100% benefit of this lesson. Okay. So each and every method you do one sums or two sums. Okay, understood? Then you put one heading types of solution. Types of solution. See types of solution here. Isotonic solution. Isotonic solution. Hypertonic solution. Then hypotonic solution, hypotonic solution. Okay. Here, 0.9% sodium chloride solution. More than 0.9% sodium chloride solution. Less than, just write one by one. I will explain. Is equal to. What is equal to? No osmosis taking place. No osmosis process takes place. Here also osmosis process takes place.
Takes place.
Takes place. No osmosis process, no. There is no movement of solvent. Okay, because I am taking one blood cells here. Suppose if you take one blood cells, I consider it as a blood cells in one solution. Blood cells in one solutions. Okay. Consider it's called blood cell. It is in what? One solution. The solution concentration what?
0.8.
More than 0.9 sodium chloride solution. Okay. Okay. More than the solution is more than means highly concentrated. This side around the cells we have more concentrated. Are you following? Okay, more concentrated means inside we consider as inside the cell is considered as it is a less concentrated, so dilute. Okay, so I told you what is osmosis. What is osmosis? Solvent moves from dilute side to.
Concentration.
It's a process. Understood? The solvent moves from dilute side to concentrated side. Okay, so around the blood cells we have more concentrated because I told you greater than 0.9%. Okay, so inside maybe less concentrated. Okay, so usually the solvent moves from what? Usually solvent moves from, correct or not? Okay, solvent moves from, it is highly concentrated now, inside means less concentrated. The solvent moves from dilute side to concentrated side. Okay, so what? The cells lie down. The cells becomes shrink. This only just keep in mind. Shrink. If a more concentrated solution around the blood cells, the solvent moves out of the cells. The cell size becomes what? Shrink. Understood? Now come to this side. Here it's a blood cell. I am taking blood cells in one solution. The solution is what? Less concentrated. Okay, this is it's a less concentrated means of inside what? Higher concentration meaning. Okay, so what happened here? The solvent moves here less concentrated, no? So what? Less concentrated means what? Dilute. So the solvent moves from outside the cell to inside the cell. Okay, now what happened side? Blood cells. Therefore what? Cells becomes, here it will be shrink. It will be what? Enlarged, no? It will be sometimes burst. It will be enlarged, that's all. Okay, this statement just right. Okay, if you have inside the blood cells, outside the blood cells having same concentration, so then only I put what? No osmosis taking place. Here osmosis taking place, here also osmosis taking place. Okay, that's right. So many choose we can able to set in this type. Okay, hyper means I remember like this shrink. Yes, shrink. R will come, no? Okay, shrink. Hyper means always Hyper means, hypo means low. Yeah. Hypo always, that's meaning for hypo. Hypo means called low. Hyper means what? High. It's a high concentration, more. Okay. Just remember like this. Here inside and outside same concentration, so no osmosis taking place. That's called isotonic solution. Understood? Hyper means high. This will be high. Outside the blood cells we have higher concentration. So we can guess inside may be low concentration. So always the solvent moves from low concentration to higher concentration. So it will come out. All the solvent molecules will come out. All the solvent molecules will come out means the cell size will be what? Shrink. It will be small in size. Okay. Okay. Right. Finished? Okay. Now, next one is one more small topic here. That is just you put the only one thing you may put Van't-Hoff factor. Van't-Hoff factor is represented by I. Okay. See here. Our aim is to only find out the molecular mass of the solute. Okay, sometimes, it's a one molecule. Suppose here three molecules are there. When you put in solution, our aim is to find out the molecular mass of the solute. Okay, but if you put in solution, put in solvent, sometimes each molecule is split into 2. For example, I am saying 2 na what? This is called splitted, no? One molecule splitted. That property is called what? Dissociative property. Are you following? Suppose the molecule is splitted into two molecules means that's called dissociative property. So what? Initially I put only 3 particle. But now it will be what? During dissociation, we have number of particle increases, no? Are you following? Okay. Number of particle increases means here number of particle increases. Number of particle nothing but what? Colligative property. I told you first. Colligative property nothing but what? Number of particle. Depends upon number of particle. Okay. So colligative property is also what? Colligative property also increases. Colligative properties increase means all the cases. Suppose for example del-TB. What's the formula? Kb W2 by M2 or not. Colligative properties increases means what is colligative properties? This del-TB is called colligative properties. See, just compare this. Del-TB increases. Are you following? What is the molecular mass? Molecular mass decreases. Down, no. Understood? During dissociation property, number of particles increases. Number of particles increases means colligative property increases. Colligative property nothing but what? Del-TB. Del-TB increases, molecular mass will be decreases. Are you following or not? Just right. Okay, this one. Then see one more thing I'll write. Then after you can copy them. This one. You tell me. Suppose I'm taking 4 particle associated. What is the meaning for associated? Associative property. During associative property, what happens? Suppose I am taking 4 molecule. 2 molecules together. Now it becomes what? This together, 1 molecule. This together, what? Therefore what? Number of particle during association, number of particle decreases. Therefore what? Colligative properties also decreases. So now you know that, therefore, I'll give an example. Therefore, what? Del TB decreases, no? So molecular mass, are you following or not? Okay. Okay. Then one more information you write. Then only dissociation, association taking place. Sometimes if you not if 5 molecules, now 5 molecules not there. Sometimes dissociation, sometimes association. Then only they introduce what? Vanta factor. It's a small factor. If you want to maintain the, if I suppose you know formula for glucose is what? 180. You know that. Theoretically we should get 180. Experimentally if you find out means that also should 180. Okay, but experimentally they are getting sometimes less than 180 or sometimes more than 180 due to this happening. Sometimes dissociation, sometimes association taking place. Then only they are multiplied by in this formula. Suppose what is the formula? Del TB. Tell me what's the formula? KB into W2 by M2 into into 1000. Then only they multiply by what? During dissociation or some association, then only they are multiplying small I value in the formula. You following? Okay. So then only we can maintain the, we can get 180 nearby, or sometimes it will be deviated from 180. More deviation will be there. Sometimes very high value, sometimes less value. If you multiply by I means it is closer to 180. Okay, understood? Just copy them this one. Dissociation na splitted, no, splitting. Association na, it should not combine. Okay. I also we got formula, 3 formulas are there. You just go through. So I'll give one formula to you now. Then here, I suppose one more thing just mention. Dissociation means, you know, number of particles increases, no? So I value will be greater than 1. This is also important one. During association, I will be less than 1. This also just note down. All the information just keep in mind. Finished? Okay, is done? Okay. Okay, see, next one is the I formula only just write one. We got 3 formulas are there. First, the most important only just copy them. I is equal to, suppose here, total number of particles. Total number of particles after dissociation. After dissociation by total number of particles after dissociation by total number of particles before dissociation. Before dissociation. It's a simple formula. Okay. Here, the last to find out the, suppose for example, potassium sulfate in solution. Find I value. Potassium sulfate in solution, find I value. Potassium sulfate means, you know, K2 SO4. When in solution means what happened? It becomes what? K2 SO4 becomes what? 2K plus SO4 2 minus. Correct or not? You put in solution, it will be, you know, ionic compounds. No, it is ionic compound. It is split into ions. No, How many ions? 2. 2 plus 1? 3 ions, no. So what's the formula? Total number of particles after dissociation. How many? Therefore what? I is equal to 3 by. After dissociation by what? Before is what? Before 1. Always 1 the. Answer 3. Just note. You have to go through the formula based, problem compulsory. Then only it will be, you can understand 100%. Now you are getting only 50%. When you go through the problem, you will be getting 75%. When you write one test, each and every lesson, you will be getting 90%. Yeah? Then when you write mock test, you will be getting 95%. When you write NEET examination, you will be getting what? 100%. Understood? Okay. So keep on study. Okay. Same concept. Okay. Suppose 4 days back one concept if you study means once again study. Once again just go through the 4 days back. It took I think 2 hours for complete one topic. Okay. But now if you see means it will take only the time will be reduced. Not that much time it will take. Now it will take today if you see means it will take only within 1 hour, within half an hour you can complete that. Okay, whatever study, just keep in mind. Okay, study the new topic as well as revise the old topic. Okay, understood? That's very, very, very important. Okay, so, but if you keep on studying means, okay, so it will forget from your memory. Okay, so revise at the same time study the new lesson also. Okay. Okay, now I given only the concepts now. Okay, so you have to go through the problem. So you see the problem solving session. I have given 7 sums. All the properties based upon one sums. Then you have first part of the lesson. No. That also I have given some sums. Okay, totally 7 sums I have given. Okay. Apart from that, you have to prepare what? Other, you have so many guides are there. Prepare. Okay. Right. Next one, first part of the lessons, that is, simply concept. First, you write concentration of the solution. Concentration of the solution can be measured by various parameters. Okay. So most important parameter means, okay, first I will say molarity. Molarity, molality, mole fraction, ppm. These 4 parameters are very important. Others are somewhat very easy one. So first I explain this one. Molarity means, what's the symbol for that? Capital M. What's the formula for that? Number of moles of solid by, okay, number of moles of solid by, molarity, volume of the solution in, volume of the solutions, somewhat different here. Solution in liter. Okay, solution in liter. So the formula, number of moles means what? What's the formula? Mass by molar mass. Volume of the solution liter, no? Okay, volume of the solution in liter. Understood? This shortcut. Same thing I am writing once again this one. Okay, just note down. Types of solution is given in your textbook. Just go through types of solution: solid solution, liquid solution, gaseous solution. Solid solution means always why it is called solid solution means solvent is solid. Why it is called liquid solution means solvent is liquid. Understood? Why is called gaseous solution means solvent is gaseous state. Okay, so they classify into 9 types. Are you following? The examples also just go through. Okay, right. Okay, see here, you write one small sums because write one sums. I think only one sums is given in a textbook. 2.30. Calculate, just write down, write fast. Calculate the amount of benzoic acid required to prepare. Calculate amount of benzoic acid required to prepare 250 ml of. Calculate amount of benzoic acid required to prepare 250 ml of 0.15 molarity solution. 0.15 solution in methanol. Okay, in methanol. What's given? 0.15 is given, no? 15. What? Number of moles of solid. How much solid? Solid is what? To prepare 250 ml of benzoic acid. Calculate the amount of benzoic acid means what? Amount of benzoic acid means what? Mass. Molar mass of benzoic acid means what? What's the formula for benzoic acid? C6H5COOH. Okay, you just, how many carbon? 7 carbon. C6H5COOH. Kata, 7 carbon. So what? 7 into 12, how much? 84. Kata not? 84. Okay, very good. How many hydrogen? 6 hydrogen. So what? 6 into 1, 6. How many oxygen? 2 into, cut or not? These are all small elements, no. Without this, we cannot able to live. Carbohydrate. Carbohydrate means what? Carbon, hydrogen, oxygen. At least you must remember these 3 elements. Atomic mass. Understood? Without these elements, we cannot able to live. Yeah? At least you carbon, remember, carbon 12, hydrogen, very easy. Oxygen is 16. So if we add all this, how much? 90, no? 90 plus 1? 92. This is 90, no? 84 plus 6, 90. 90 plus 32, 120. Cut or not? Check. 122. Cut or not? Okay. So what? 122 by volume of the solution in liters. How much ml? 250 ml is given or not? 250 ml by 1000. That's all. Multiply, you can get mass. Understood? This will be what? 1 by 4. This will be 1 by 4. If you multiply, it means what? 0.15 into 1 by 4, which is equal to mass. Yeah. Again, this also you multiply into 122. If you simplify, means you can get answer. Understood? Just note down. Just note down. You simplify yourself later. Understood? It's a simple sum. These are all already asked. 2016, 17, 18. You are all going to get one new sums. 2023. No? These are all already asked. These kind of sums. Okay. Same thing. Molarity means volume of the solution in liter. Yeah. We should measure in liter. Molarity means it should be in kilogram, that's all, simple. But solvent should be in kilogram. There's small correction, okay? Finished? Okay. See, right, next one is, molality, M-O-L-I, mola, M-O-L-A, molality, small m, understood? Same formula, and small correction, number of moles of solute by, okay? Mass of the solvent in kilogram, this is the important one, mass of the solvent in kilogram, okay? As usual formula, same formula only. If you want me, just write mass by what? Molar mass by, as usual, this also, mass of the solvent by, 1000, okay? It's called, molality. Yes. 1000. Mass of the solvent in kilogram. Mostly 250 gram only they will give. 250 gram not by 1000. So 500 means 500 by 1000. Then only I simply formula itself I introduce everything. Okay. So it will be in safer. Suppose 1000 gram means you put 1000 here. 1000 can cancel. Understood? Okay. Then only I introduce formula itself. I introduce 1000. Okay. Understood? I will give one sums, you can do yourself, how to do. Molality we have done, no, already, okay. Simple sums I will give. Calculate, right first. Calculate mass of urea. Calculate mass of urea. Mass of urea, in bracket, right? In bracket, right? NH2CO, NH2. In bracket, right? NH2CO, NH2 is a formula for urea. Okay. Calculate the mass of urea required in making 2.5 kilogram of 2.5 kilogram of 0.25 molal aqueous solution. 2.5 kilogram of 0.25 kilogram of 0.25 molal aqueous solution. Okay, same we have done no previous sum. There also we found out mass, no, this also we have to find out the mass. So what's the formula for molality? Mass by molar mass by mass of the solvent in kilogram. That's all. So here, what is this? Molal. Okay, it's substitute. 0.25 is equal to what? Mass is what? Mass we have to find out, no? By molar mass, what? Urea formula is what? NH2CO, NH2. Correct or not? 2N, no? 2 into? Last time I told you carbohydrate. Now we need protein also, no? Yeah, we need protein also. So protein, who is there? Nitrogen is there. So nitrogen atomic mass is 14. Okay, so 28. Understood? 4 hydrogen, no? So what? 4 into 1, 4. 1 carbon, yeah? Correct. 1 into 12, 12. 1 oxygen, no? 1 into 16, 16. Are you following? So if you add all this, $60, correct or not? Check. $60. Yeah, so you substitute here. Molar mass, no? 60. Okay, by what? 2.5 kilogram. Yeah, understood? 2.5 kilogram means, but in this place, if you put means what? Gram. Understood? Don't. In this place, so mass of the solvent in, mostly I told you, mass of the solvent in gram only. Then only I put 1000. I introduced 1000 in the formula itself. Okay. So what? 2500, correct? By 1000. Then you cross multiplication. Okay, now cancel, no? Cancel. This one is what? 5 by 2. 5 by 2 into 60 is equal to what? Mass. That's all. Find out. Understood? Next. Then one more term I introduced. Clear of this. The third term is, mole fraction. Mole fraction, I told you, it is represented by, what's the symbol? X, okay. It is related with, just write vapor pressure, the term important. Vapor pressure. Suppose here, mole fraction of, 1 represents what? 1 represents? Solvent, okay. So simple, 1 is there means here N1 by N1 plus N2, this is a formula, just remember. Okay, 1 number of moles of solvent by total number of moles of all the solution, total number of moles of the component in the solution. Suppose X2 is a formula, what? N2 by N1 plus N2 is a formula. Okay, just keep in mind. Then suppose here, what is X1 plus X2 1 is a formula. Suppose for example, X1 we are finding 0.6. X2 did not find out. So what? 1 minus? X1 How to find out X2 means? X2 need not find out. Once again, this we put everything here. You just subtract. 1 minus 0.6 means we get what? 0.4. Okay, understood. So this is a state. If not only X1 plus X2 plus X3 together, we can consider is what? If you have 3 component, 4 component means always 1 only. Okay. Understood. Okay. You see the formula. Suppose here, based upon we have some is there. Example 2.1, 2.1, example 2.1, in text 2.1. So if you go through, not 2. In text we have, I think 2.2. Example 2.1, in text 2.2. So this kind of sum, if you go through, means you can able to understand all this. Okay. Here N1, see, this is a formula for X1. It's a N if we know means then only we can substitute. No, they will not give N. They will give only gram. Because for example, 20 gram of, for example, glucose. Okay, in that suppose here 180, 500 ml of, not ml, both should be in same quantity. Okay, 20 gram of glucose in 500 gram of water. Find out mole fraction. Mole fraction, we need what? If you want to find a mole fraction, we need what? Number of moles, yeah. But number of moles is not given. First, we have to find out the number of moles. How to find it for this? This is a solid. This is what? Solid, no? Solid, no doubt. This is what?
Solvent.
No doubt, isn't it? So solid means here X2. Correct? This is called x1. So x2 means this is x2. Okay, so right. x2 if you want to find means we need n2. Then only we can find out. Yeah. n2 means what's the formula? W2 by W2 by M2. W2 is, you know what? 20 gram. Correct? By molecular glucose is what? 180. Then only we are getting what? N2. Understood? Here. What is N1? Mass by molar mass. 500 by what? 18. Then only we get N1, N2. Then substitute here. Then only we can get X1. Okay, they will not give number of moles directly. Okay, they will give gram. So gram into number of moles into mole fraction. So these are the steps are there. Okay, just note on. Just the examples. You put examples. 20 gram of glucose in 500 gram of water. Just mention all this. Then we can able to solve the sums. In text we have 2.2. Example sum we have 2.1. Okay. Understood? So only one formula I will give. So mostly it covers everything. Concentration of the solution. Okay. Finished? Then fourth one is ppm, parts per million. Okay. Fourth one is parts per million. This first three terms is very, very important. Mole fraction, molarity, molality. Okay. Then okay. Parts per million, ppm, just write. Fourth term is what? Parts per million. ppm, simply you can write ppm. Okay. PPT is also there, not that PPT. Not PowerPoint presentation. That is called PPT means parts per thousand. Okay, parts per thousand. This is called parts per million. Okay. Okay. Just we are comparing. That is 1 gram in 10 power 6 gram. That's all. Simply. 1 gram compared to 1 million means what? 10 power 6. We are comparing these two. We are comparing small quantity in larger quantity. Okay. That relation only is called what? Parts per million. Okay. If you take sea water, salts are there. Okay. So here 1 gram of salt in 10 power 6 gram of that solutions. So we are comparing the small quantity with bigger quantity. It's called parts per million. Okay. Or for example, dust particles in the atmosphere. Okay, atmosphere is very large surface area, no? Okay, so in that dust particle is very, very small thing. Okay, we are comparing. Suppose dust particles in atmosphere. That is the best example for parts per million. Okay, so here we have one formula for that. You just write the formula. ppm is equal to, okay, write the formula. One statement is given in your textbook. Number of parts of the component by, see, number of parts of the component by total number of parts of all the component in the solution. Total number of parts of all the component in the solution. All the component in the solution. This also I gave some sums in problem solving session. So if you see means you can able to understand all this. Okay. 10 power 6. Okay. Okay. So suppose in our sample we have 2 gram is there. Sample means a large quantity, but the ions will be only 2 gram. So 2 gram in 500 gram into 10 power 6 means we are getting ppm. Understood? So small quantity and larger quantity we are comparing. Okay, understood? That's why it's called parts per million. Okay, million measurements here ppm, ppt means 1000. It will come 10 power 3 means what? It's called ppt. Understood? Parts per parts per 1000. Understood? Okay. This also I given one sums. Okay, molarity. I think see the problem solving sessions. Molarity based on sum, ppm based on sums. Okay, Van 't Hoff based on sums. Then colligative properties. Other 4 sums are based on colligative properties. 4 colligative properties. Okay, maybe I think a freezing point, osmotic pressure, lowering of vapor pressure. Okay, all the 4 properties based I given on sums. See that problem solving session, you can able to understand all this. Okay, here only one left is the Raoult's law, Henry's law. These 2 only I will teach in the next class. Okay, thank you, students.